cancel it out.
Yes, exactly. Okay, let me just explain it. Antiderivative of f of x. So the most general would have been f of x plus c, indeed. So once I have to evaluate it at b, it would have been f of b plus c minus, I evaluated as at a, and yes, when I distribute the negative sign, c goes away. So that's why I end up having f of b minus f of a. And this is the fundamental theorem of calculus. It's considered part 2 in this book. So part 2 in this book. Okay. I would like to mention one very important thing. So we have 2 types of integrals. One that is definite, which is the integral from a to b from f of x dx. The other one, which is indefinite. Now, before we talk about the indefinite, can anyone tell us what would be the answer of a definite? Always.
Absolutely. This number,
A number. Always. A number, whatever that is, it will always be a number. Now, the indefinite does not have limits of integration. So these are called limits of integration. A and B, limits of integration. The indefinite integral does not have limits of integration. And the answer will always be a function. Always a function.
approximate.
No, because we don't have limits of integration. So the integral from f of x dx is indeed f of x plus a constant c. So this is the same with the most general antiderivative of the function. So the indefinite gives us a function that we differentiate to get this. The definite always gives us a number. 15, 16, 5 over 3, 8 over 9, whatever it is. But that is always the case. Now, which of these two do you think we can check?
The second. Well, second, sure.
Second for sure.
I don't know if you can.
If the number is 5, I have no idea whether it's true or not. Or if it's 8/3, I have no clue. But this, and this is the fundamental theorem of calculus, part 1. I'm going to talk about part 1 right now. So note, the only integral that we can check is the indefinite one. Only. So the fundamental theorem of calculus part 1 says that differentiation and integration are operations.
Reversible.
I'm missing a word. You're close.
Inverse.
Excellent. This is what the fundamental theorem of calculus part 1 is teaching us. That differentiation and integration are inverse operations. And this is what I'm going to do here to show you that when we differentiate both sides, we will get the function. Okay, so give me an integral, an indefinite integral of any function you would like. Don't make it difficult.
X squared plus 2x plus 3.
Let's find this indefinite integral, which is a function, and it has to have plus a constant c. So which function prime is x squared?
X to the third
Plus
2
x squared over 2, and I'll simplify. Plus,
3x.
yes, plus. Very good. So we determined the most general antiderivative for this function. One more time, the notation is important. This is f of x. This is f of x, uppercase. And now I want to show that this is correct. To show that this is true, what this? All this. Differentiate both sides. And now this is what the fundamental theorem of calculus part 1 is teaching us. When I differentiate an integral, I'm basically canceling this and this. So the left-hand side is x squared plus 2x plus 3. Let's see what we have on the right-hand side when we differentiate. Can anyone dictate? And this happens because differentiation and integration are inverse operations. Now, I told you that the integral from a to b from f of x dx is, what did we say? What does this equal to? Right, true. That's the fundamental theorem of calculus part 2. But what is it always equal to?
F of x.
True.
Let's see.
What else? Okay,
Ah, that's what you're getting.
a number. Now, please pay attention here. This is very important. The integral from a to x from f of t dt. Okay? So let's look at this. Don't say anything just yet, please. Okay? So this that I just shaded, what is it?
B minus
The integral from a to b from f of t dt. And it's the area. We know that. But now I'm going to say x is a number between a and b. Let's say here. Here's x. Can anyone dictate this?
same thing except swap B for x.
So what will you dictate? The integral from
X to
a
A
to x from, okay. Now imagine that I'm moving x. I want to move x here. So now can you dictate this? Which I hope you agree is going to be a different number, correct?
It'll be a different number.
Okay. So please dictate this area. The integral from
A to x.
f of t dt.
Yeah.
Okay, I'm moving x now again. Every time I move x for any input x, what do I get? A different number. But what does this mean? When in something I put x and I get different numbers. What is
It's a
that?
function.
Exactly. So this is a function. So g of x is the integral from a to x from f of t dt. Yes? Yeah.
What happens if you have an equation like, but it goes like this across the axis like sine does? At certain points, would that still be considered a function, but it will equal the same value every now and again as the positive and negative hemispheres cancel each other out?
So you're talking about the area?
Yeah.
It's a very good question. I was going to get to that in a minute. So I'm going to stop here for a second to answer. So for example, are you asking whether a function is odd or even and what happens to the area?
No, I was just saying that you said because you get a different value of x that makes it a function. What happens if you have
Because this is x. Because this is x. It's not a number.
Okay, well, I was just saying like if you have like g of x equals a function where it goes like this across the axis and at certain times it will cancel each other. Like they'd be the same area and cancel each other out.
Right. That's what it is. It's an odd function.
Okay.
So let me give you an example. So for example, if you would like to think of sine. So if you have just this interval, right, between negative pi and pi. This is a positive area, this is a negative area. So if you want to determine the integral, I was going to just get to this. These are two properties, but that's fine. So negative pi to pi from sine x dx. Okay? Yes, that's true. Because the function is odd. Function is odd, and that's not enough. The interval is symmetric around 0. And the interval is symmetric. That's why it's 0. So if the interval is symmetric on any integral, if you give me any integral to solve, and I see that the interval is symmetric, the next thing I think of is whether the function, or I check whether the function is odd or even. If the function is odd, I will write 0 and I will make this note on paper. Say, function is odd and the interval is symmetric. So the answer is 0. What happens with an even function? I didn't finish this. I'll come back in a minute. So this is for an odd function. What happens now if the function is even? Exactly. So if I have this situation, this is an even function, and this is negative a to a. So for example, if I have the integral from negative 3 to 3 from x squared dx, the area will be this. And it's always easier to determine twice the area from 0 to 3 from x squared dx than plug in negative 3 at the end in f of b minus f of a. But this happens for even functions. For any even function, if the interval is symmetric. So even function and symmetric interval. Because if you see, okay, the integral from 0 to 5 of x squared, it's not twice the integral from something, right? Because the interval was not symmetric. So every time the interval is symmetric, you should always think of analyzing the function and checking whether the function is odd or even. If it's odd, you don't have to think of anything, just put 0. But you have to explain why. If it's even, then you will write 2, the integral from 0 to 3 from whatever, and this is always easier to calculate than this. Always. Okay, so is this what you had in mind, roughly?
Yes.
Okay, so let's come back to this. So we know now that that is a function, and we have tons of situations in which we are asked to find it. Okay? So I'm going to pick a problem from okay. Find the derivative of the function. Find the derivative of these functions. Okay, and I would like to start with
Derivative, not the antiderivative.
no. Very good question. Very good question. I don't want to start with these. Okay, 14 first. On page 394. So the integral from 1 to the square root of x, z squared, over z to the fourth plus 1, dz. This is a function of, no,
No,
of x. This is a function of x, because the variable is this. If this were a number, this whole thing, the whole answer would have been a number. This is the problem. The fact that this is x, that's why this is a function of x. Otherwise, it would have been a number.
not a function.
And not a function, right. But since this is a variable, and it can be anything, then this is a function because of that. So we are not ever, in these situations, we're never asked to find anything else but the derivative. So I will differentiate the left-hand side, and I will differentiate the right-hand side. I'm asked to find the derivative, so the left-hand side is g prime. So what do I get on the right? What I get is I have to replace z everywhere by the square root of x. So I have the square root of x squared over the square root of x to the fourth plus 1 multiplied by the inner function prime. If this were just x, the answer would have been, see, I didn't finish here. Sorry. So now when we differentiate both sides, we get g prime of x equals f of x. I wanted to answer the question and I didn't finish it, sorry. As long as this is just x, but if this is a function of x, then I have to multiply by u prime of x. So now when we differentiate the left-hand side, we've got g prime. When we differentiated the right-hand side, as you recall, the derivative cancels this. But since it's this has to be plugged in, it's f of x. This is the x, but it's not plain x. It has to be multiplied by the square root of x prime. Yes?
No, this is for like if the square root of x is a maximum. Does it matter?
Absolutely. Absolutely. If I have the limits reversed, it could be. I could have here x squared and here 5. First, I have to reverse them.
You do that.
How do I do that? By simply reversing this, changing the sign in front.
Okay.
Very good. Very good. Okay. I haven't finished, but I have to answer this question. I'll come back in a second. The integral from a to b from f of x dx is the opposite of the integral from b to a from f of x dx.
Okay, I get it.
So yes, and we will have examples in a minute. I'll have examples in a minute. So let's finish this up. So g prime is the square root of x squared, which is x, the square root of x to the fourth, which is x squared plus 1, and this is 1 over 2, the square root of x. You can rearrange it if you want a little bit, and I will put like 2 x squared plus 1, the square root of x. And this is the function. This is a derivative of this function. So this is an integral, but it's a function because this is a variable. When we differentiate both sides, the left-hand side is g prime. The right-hand side is this, but with that function plugged in, or the variable or function plugged in. Since it's a function, not just the plain variable, I have to differentiate by the inner function prime. Okay, so let's look at a few more examples. So I need to practice this. So now, here's an example with the reversed. Yes, 18. Very good question. Sine x to 1, so this is the function. The square root of 1 plus t squared dt. Can anyone tell us what is the variable in this function?
Sine of x.
Yes, it is g of x. I'm asked to differentiate the left-hand side and differentiate the right-hand side. However, I cannot do this before I reverse. So, and I write this. Negative in front from 1 to sine x, the square of 1 plus t squared dt. Yes, it is a must. So I cannot differentiate unless the function is presented like this. This can be anything. Anything, it doesn't matter, but it must be a number. So now I'm ready to differentiate this. What do I get? Minus stays outside.
The square root of 1 plus sine of x squared
Very good. Sine squared x, good. Times,
cosine x.
that's it. Excellent. This is the function defined as an integral. This was a function defined as an integral. Its derivative is this. Now, this is the most complicated situation. 57, for example. Function f of x, the integral from x to x squared from e raised to t squared dt. It's not complicated, but it's the most difficult one if you want, in a way. It needs preparation. And here's the preparation. Before I explain this, I just want to draw your attention to the following. Here's a function. Bless you. Wait. Just
I was trying to figure out how many symbols I could say.
Cube or
the fourth power.
Yeah.
Okay. So here it is. Can anyone tell me, and I know for sure that everybody will say the right thing. Is there any way I could present this as a sum of two integrals?
Yes.
So this will be the integral from a to b from f of x dx plus
B to C.
from f of x dx. Good. So then, that's all I need to do with, this is x squared. I have to break it up somewhere. I don't care what you put in there. It's the integral from x to whatever number you want, plus the integral from whatever number you want to x squared. Break it up anywhere you want. You don't even have to tell me where. I don't care. And this is e to t squared dt, e to t squared dt. I have one more step. This is okay, but this one is not okay. What do I do with this?
Flip it and make it negative.
Yes. So then f of x equals negative the integral from whatever you want to x, e to t squared dt, and plus from that to x e squared to x squared e to t squared dt.
So the variable is just at the top.
It cannot be at the top, yes. So now f prime of x. Yes,
Why did we split it up to begin with?
because, very good question, because both are functions. This is,
You can't have a function.
you cannot have a function at the bottom.
That's why we have to switch it once we
Exactly,
put in a number.
exactly. So now I'm ready to differentiate. Please tell me what to write.
f of x
Negative, f prime is negative,
e to t squared
but t squared now becomes x squared
x squared
times the inner function prime. Is there a need? No. Plus
E to the x plus 4
X
times 2x.
times 2x. This is it. I'm going to choose one for you, 59, because you are all too relaxed. So we have y equals the integral from cosine x to sine x from natural log of 1 plus 2v dv. Why? You can use any variable. It doesn't have to be t.
It's not like it's rocket science. Yeah. And we're allowed to use any number we want when we divide them, right?
You can put 0 in all cases. You can put a number like I put it, a number sign. You can put pi. You can put hey. You can put anything you want.
And,
As long as, yes, as long as, because it will not come into play at all. It all depends on the function, not the number you start.
They want to enter any place. It's not like they're going to play.
We like that,
It's not bad, it's obvious.
it just exists.
I wish we could put up numbers in this.
Just like
I don't like that, it's simple. Like this one.
Of course, there are conditions. The function has to be continuous and differentiable, of course. After this, I would like to practice both integrals, the definite and indefinite.
This is like when we have like a quadratic equation or something, we plug in t equals x squared almost.
You're thinking about the substitution rule for equations that are quadratic in form.
Yeah.
I wouldn't say that.
The substitution part.
Okay. So can anyone dictate?
So we have to split it, and after you split it, is it okay if I split it into the negative thing on
That's
the side?
fine. That's fine.
So negative the thing cosine x, and then
The integral
yeah,
and plus.
same thing except sign and it's on negative.
Good. Now it's ready. So y prime would be.
Sine on.
Okay, we start with sine. That's fine. We can start with the second one. It doesn't matter.
No, I started with the first one because the derivative of cosine turns into positive.
Okay.
Because
Okay.
cosine is negative sine.
Okay. So natural log of 1 plus 2 cosine x multiplied by sine x, and it took care of that. Plus.
Natural log of 1 plus 2 sine x cosine x.
Go to the trash.
So
They're horrible. I just bought them, and they had just a tiny little bit. Don't buy these.
Well, I
had
don't know if
just-
Brandon will, but also we just said don't know.
Don't buy these.
Oh,
Good. Any questions on this?
I thought you had to do like the
So when I-
differentiate ln of x and get like
No. No.
You just
One
plug it in.
more time. G of x is the integral from a to x from f of t dt. G prime is f of x.
Oh, I made my life
Because
harder.
when you differentiate this side, the integral goes away.
Okay.
Okay?
Yeah.
Good. I would like to practice definite and indefinite. So You want to start with definite or indefinite?
Indefinite.
Okay, very good. So let's start with indefinite. I would like to start in that case, with number 12 on page 404. Yes.
Very good.
The integral from x squared plus 1 over x squared plus 1 dx. This is very similar to what you had on the quiz today. Will this be a number or a function plus c? Good. So can anyone give us the answer?
I can give you the first two terms, I guess, for the third. Plus x.
This is a very important function. Arctangent, please.
That was it.
Plus,
Plus c.
very important function. The integral from 1 over x squared plus 1 or 1 plus x squared is arctangent x.
What
Please.
was the,
Sine,
arc
arc sine. Okay, let's write them one more time. All those three that I please kindly ask you. Sine inverse prime is 1 over the square root of 1 minus x squared. Cosine inverse prime is
so I think it's a plus.
the same thing but with minus in front, outside. No, nothing changes underneath. And tangent inverse is 1 over 1 plus x squared, or if you want to write 1 over x squared plus 1, the same thing. Please, these three have to be memorized. Okay, here's the next one, number 16. The integral from secant t, in parentheses, secant t plus tangent t, dt. 1 minute. We don't know anything about products. We don't know we have not studied that. We have to use integration by parts, but we don't know that till calculus 2. So, since I don't know products, what should I do? I should distribute first.
Yes, that's what I was looking at.
Good.
You have to multiply the secant by the secant by the secant.
Exactly. Good. So please multiply first.
The secant was that? I think that. Yes, answer the question started before that.
Was it?
Yes.
So I've been told. Rumor has it.
I'm ready when you are.
Okay.
Yes, tangent squared is secant. Tangent prime is secant squared.
I guess what that was.
That's a
Plus,
cosine.
which function is secant tangent?
Secant.
Secant. Plus a constant c. So tangent plus secant.
Can we go over all those again too?
Which ones?
The trig identities as far as
Right. Let's suppose you forgot what is the derivative of tangent. What will you do?
Take the root of cosine and turn it to the root.
So no, we forgot what the derivative of tangent is. So I'm going to replace it by sine t over cosine t and differentiate using the quotient rule. Sine prime is cosine times cosine minus sine times cosine prime over cosine squared. But how much is cosine squared plus sine squared? Cosine squared plus sine squared. 1. And how much is 1 over cosine squared?
I forget that sometimes, that 1 over cosine and secant.
1 over cosine is secant, yes. So secant squared. So tangent prime, if I forget, it's secant squared. What if we forget secant prime?
Isn't it 1 over
Cosine.
cosine?
So it's cosine to -1, but that's not inverse function. So it's -1 times cosine to -2 times the inner function prime. So what minus with minus will go away. So this is sine t over cosine squared. And you have to split it. So you have to split it into sine t over cosine t times 1 over cosine t. So it's secant tangent. So yes, let's write them one more time from the beginning. All 6 trig functions. Sine prime, cosine prime, tangent prime, cotangent prime, negative, secant prime, yes, cosecant prime, that's it. Very good.
And
Yes?
cosecant is 1 over sine, or?
Yes. If it starts with C, it's 1 over S, sine. If it starts with S, it's 1 over C,
Okay.
cosine. Okay, let's look at a few definite now. We still have time.
Sine squared plus cosine squared is 1.
Yes. Okay, let's look at 28 on 404. The integral from 1 to 2, from 1 over x squared minus 4 over x cubed dx. Does anyone remember a long time ago we were discussing but not mentioning the integral this? Which function prime is 1 over x? ln. Actually, the absolute value. Natural log of the absolute value of x plus a constant. Good. Okay, so I recommend, till we get used to this, I recommend changing it into x to -2 minus 4x to -3. Because I already know what function prime is 1 over x squared. But you don't have to. So I changed it into x to -2 and 4 times x to -3. And now this is pretty straightforward. So let's find the antiderivative. I'm sorry. Let's find the integral, the definite integral. But first we need the antiderivative. Yes, over, right? So it's x to the n plus first over n plus first. So -2 plus 1 over -2 plus 1 minus 4 x to the
2.
Negative 2 over
Negative 2.
negative 2. So I will write now negative 1 over x plus 2 over x squared. To simplify it, what do I do next? Plug it in. And remember, you have to subtract. When you plug in 2, you will have negative 1/2 plus 2 over 4, which is 1/2. When you plug in 1, you will have negative 1 plus 2. But how much is negative 1/2 plus 1/2? How much is 2 minus 1? With minus, with minus in front, it's negative 1. Very good. Very good. I'd like to start working on the substitution rule now, if that's okay. Is that okay?
Yes, you're the teacher.
Okay. Substitution rule for integrals. Okay,
At least at 11 o'clock, you still have
14 on page 413.
It's questionable.
The integral from u, the square root of 1 minus u squared du. Of course, I will start with the indefinite integrals and then we'll move on to definite integrals. You just gave me this integral and I'm looking at it and I'm looking especially at this function and I realize that this is what bothers me. This is not a scientific way of choosing the substitution, but it's a useful way. So if I can get this out of the way, because see, the square root of a plus b or a minus b cannot be simplified. There's nothing I can do to it. So if I could just get this out of the way, then the rest should be easy. So I'm going to say let t be 1 minus u squared. So I want to replace this portion by the square root of t, which is much easier to handle because it has only one term under the square root. But now I have to see what I can do with these, because I can't have t and u in the same integral. That's not possible. So how do I determine du? Well, I'm going to differentiate both sides and I get dt equals what du? Negative 2u. So I'm happy. Why am I happy? It's because I'm only having a problem with a constant. Well, I can multiply by negative 2 and divide by negative 2. And now this is exactly my dt. Can anyone dictate the new integral? Negative 1/2, the integral from? That's it. What did I accomplish? I changed the integral from something way more difficult to calculate into something much easier to calculate using a substitution. One more time, how do I choose the substitution? I look at this function and I say, well, u is not that bad. The square root is not that bad, but this quantity under the square root is really in the way of me simplifying the function. So if I could get that out of the way, then assuming that dt is somehow in the problem, because if I cannot make the dt, then my substitution is not the right one. So I said, okay, let's try and see if I denote this by t and differentiate both sides. The left-hand side is dt, the right-hand side is negative 2u du. This becomes the square root of t, and now I have a u times du. That's good. I don't have the negative 2. But numbers will never bother me because I can multiply by negative 2 and divide by negative 2. So now negative 2u du changed into dt. And this part is nothing else but the square root of t. Of course, I still have a negative 1/2 in front, but it doesn't bother me at all. So the final answer will have t to 1/2. So t to 1/2 plus 1 over 1/2 plus 1 plus a constant c. So this becomes 3/2, and this is 3/2, and I flip it. So negative 1/2 times 2/3 times t to 3/2 plus a constant c. Yes, I will simplify and get negative 1/3 t to 3/2 plus c, but I cannot leave the final answer in t. Then what do I do? Replace t by this is how the substitution rule for indefinite integrals works. The final answer must be in the variable given in the problem, though. Any questions?
Yeah.
Go ahead.
I get the part where we plug in t, and I get taking out back t, putting back in the original thing, but I don't get why it's d of t equals, and I don't get where the 1 over negative 2 comes from, and all of that. I don't get this.
Okay. Okay. So if you remember, if I have a function, let's say f of x, which is 1 minus x squared, if I need to determine the differential of this function, I have f prime of x is negative 2x dx.
Right.
Right? So this is a function t, which is 1 minus u squared. I differentiate to get this, or if you want, I can replace this by dy over dt or dy over dx, and then I multiply both sides by it. Same thing, right? A long time ago, when we discussed approximations, if you remember, we were talking about the differential of a function. So we said the differential of a function is dy equals f prime of x dx.
Right.
And this is a function, which is this. So when I differentiate it, I get dt or dy in the formula from a long time ago. I differentiate this as negative 2u. This is this part. And then du, which it takes place of dx. So I need to determine the differential of the function because I need to find this.
So the negative 2u would go in where the du is.
No, du is dt over negative 2u. So that's why it's one way. Just solve for du and then plug it in here. Or once you see that it's dt negative 2u du, you have du, you have u. The only piece I'm missing is this negative 2. So I can multiply by negative 2 and divide by negative 2. And this doesn't do anything. I can go back and it's just 1. So if I multiply by negative 2 and divide by negative 2, it's multiplication by 1.
So you're saying that like the 1 over negative 2 and the times negative 2, that was just balancing the function?
Exactly, because I needed a negative 2 in there.
So du equals...
So yes, if you want, you can replace it by that. Yes, you can solve for du if that's what you want.
And then, okay, so...
And then you replace it in
I
here.
could just find dt and then solve for du, plug that in.
And exactly.
Solve
And you'll
like
get the
regular.
same thing. Yes.
Okay.
Yes.
That makes sense.
If that's better for you. Yep.
Yeah.
Okay, so let's look at other examples. Yes, number 18. So the integral from sine of the square root of x over the square root of x dx. I know that this sounds, not scientific, and it's not. But what bothers you? What bothers me is sine, a function in sine. This is a function plugged in sine. I don't like that. So I wish I could get rid of it, because I know what function prime is sine, but I don't know what function prime is sine of the square root of x. So this is what bothers me. A square root inside sine. So I'm going to say let t be the square root of x. What do I get? dt equals times. Good. So I'm almost there. Again, I'm missing a 2. That's not a problem. Multiply and divide. And what does this represent? dt. And what is this now?
Sorry, T.
So what is the simplified form after using the substitution rule? But 2 outside?
Yeah, two.
Sine t dt. So dx over 2 the square root of x is this, which is dt. Sine of the square root, which was denoted by t, it's sine t. And now this cannot be easier. What function prime is sine t? However, I cannot leave it as is, because it's an indefinite integral, and the final answer has to be a function in the given variable. So negative 2 cosine plus a constant c.
So the whole thing, when you take the derivative, equals dt? No.
So what we claim is that the integral from sine the square root of x over the square root of x dx equals negative 2 cosine the square root of x plus a constant c. Very good question. We want to show that this is true. We are going to differentiate the left-hand side, and we are going to differentiate the right-hand side. Now, this I have to be very careful, because it's the quotient rule, or I can change it into the product rule. Okay? So let's see what is the best thing to do. Maybe x to negative 1/2. Oh, I'm sorry. The left-hand side is sine the square root of x over the square root of x. Okay, I was not thinking. Okay, the right-hand side, negative 2 times negative sine the square root of x times 1 over 2 the square root of x, and c prime is 1. So, so this is sine the square root of x over the square root of x. When we differentiate the integral, this goes away. So we have sine the square root of x over the square root of x. And minus 2 cosine the square root of x. So negative 2 cosine prime is negative sine times the inner function prime. I simplify to negatives, make a positive, so I have sine the square root of x over the square root of x, and that's exactly what the left-hand side is. It's a lucky situation, because the definite integrals can be checked. The definite integrals cannot. The indefinite can. Good. What about 24? Any questions? 24, the integral from the square root of x sine 1 plus x to 3/2 dx. Okay, so let's work on this for a minute. Can I ask you what bothers you when you look at this function? Which function? This is the function I'm talking about. Exactly. That bothers me, because it's something weird inside of sine. And I don't know, I only know what function prime is sine x. I don't know what function prime is sine of something else. Yes, that's where I would start. And I would say let y be 1 plus x to 3/2 and see what happens. You will find soon enough if this is not the right substitution, because you will not find dy in there. So if you find dy but minus some constant, that's fine. That's not a problem. This is good, isn't it? So what would you do? You will multiply by and divide. So you have to, if you're putting in a 3/2, you have to put a 2/3 as well, because you have to have 1.
Oh,
You cannot just say, oh, I'm going to put a 3/2 in there.
but it's not right.
Yeah, I know. But if you put in a 3/2, you also have to put in a 2/3. So you are multiplying and dividing by 3/2. So therefore, what is this? Okay. And what is this? Thank you. That's okay. So then I have a 2/3 outside, and I have the integral from sine y dy, which is very elegant in comparison to what I had before. But please remember, if you're taking the liberty of putting a 3/2, you have to balance it out with a 2/3, because this has to be 1. So then 2/3 outside, which function prime is sine y? So I put a negative in front and cosine y, plus a constant c. So it's negative 2/3, but I have to go back to the variable I was given. So I have to have then cosine 1 plus x to 3/2 plus a constant c. Any questions? Is this okay?
I still don't get the.
So I took 1 plus x to 3/2 and I said, let's call this y.
I get that.
Because I don't like this in there.
Right.
I'd rather have just sine y. So I differentiate, I find the differential of y, which is dy times this prime dx. Correct? 1 prime is 0. Bring down 3/2, subtract 1 from the power. I have x to 1/2 dx. But x to 1/2 is the square root of x, which I have right here in front. So the square root of x times dx, and I'm missing a 3/2. 3 over 2, 2 over 3.
Oh, we try to make it match.
Exactly, I have to. Or you can solve for dx, as you mentioned before.
So we have to see whatever dy equals.
Exactly.
See what we have.
If I don't have dy, exactly.
We don't have.
Yeah, exactly. Coefficients are fine. But if I don't have the rest, like the square root of x, I cannot make up the square root of x. I can make up a 3/2, as long as I multiply by 2/3.
So
But
then, sorry.
no.
So then you'll end up whatever your coefficient is. because that should be the only thing.
Right.
You don't have.
So that's all I
you
don't.
flipped, and then you multiply that by.
Yes, because this is 1 now. 2 over 3 times 3 over 2 is 1. I'm not changing the problem. Multiplying by 1, I'm not changing the problem, right? So now 3/2 grouped with this and with this will make the dy. And this will be sine y, which is very straightforward now. 2/3 negative cosine y plus c. Is this better?
Yeah.
Okay. Okay, let's choose another. Let's say 32. Sine of natural log x everything over x dx, and I said this was 32, yes.
What page is this?
Page 414. So sine natural log x, everything divided by x dx. 2 minutes. Seems like I'm choosing all with sine.
Almost as a hint for our test.
And then I like to look at 44. And yes, this one does not have sine in it. This is not the only way. I think that this is the simplest possible way to find an integral. But if you, when you read the book and you decide that that's a better method, please use it.
Right.
So you said, okay, yes, yes. Yeah, don't forget to put the integral symbol in front. The integral symbol. Otherwise, it makes no sense.
Right. Yeah.
In front of right here. In front of, yes,
yeah.
right there. Can anyone suggest anything? Yes? You?
I use t. So t
Okay.
elements. And then
So the differential of t, dt, equals,
1 over x dx.
and that's exactly what I have. So this is dt. So this is the integral from sine t dt, which is negative cosine t plus c, but I have to go back to the notation.
Should be negative sine ln x.
Negative cosine of ln x plus c.
There we go.
We have to go back to the original variable. It was negative cosine t plus c, so it's negative cosine of natural log plus c. Is that okay?
Oh, because the answer derivative is negative cosine t sine.
44, please.
That whole derivative is
44. I will not start the definite integrals with substitution rule today, but let's do this one. Can anyone think of a substitution? Let's take it by elimination for a moment, and then you'll understand the pattern. What bothers me in this function is the fact that there are 2 terms in the denominator. That's one thing that bothers me. So don't write this, because it's not going to work. So if I say, okay, let me try this, then I'm in trouble, because dy would be 4 x to the third dx and I can't make up an x to the third. So this is not the right substitution because I can't make up the dy. Okay, then I'm looking at this. Exactly. So if I denote by y, I denote x squared by y, then I have dy, which is 2x dx, and this is definitely the correct route. I am missing a 2, right? So what? Missing a 2 is never a problem. I can make up the 2, divide and multiply by 2. And then the integral becomes the integral from what? So dy over 1 plus y squared. But I know this. I just reviewed it a few minutes ago. Which function prime is 1 over 1 plus y squared? Arctangent. Please don't forget that because it's a very important function. So I have 1/2 arctangent y plus a constant c. So even if you cannot see or cannot find the substitution from the beginning, think of something. Find something, differentiate it, and then think about it. So the final simplified form will be 1/2 arctangent x squared plus a constant c. Indeed. We want more, or you want to stop?
More.
More? Very good. Excellent. So let's look at, 38. Look for more paper. No, I do have it. Right here. So 38. The integral from dt over cosine squared t multiplied by the square root of 1 plus tangent t. Let's think for a moment, then please come up with an idea. From all this, which portion you don't really like? Yes, the square root, but I can't eliminate the square root.
The 1 plus tangent.
Exactly. Yes, that's what bothers me because I cannot split it. I cannot simplify. It's the square of a sum of 2 terms and I can't touch it. But if I can replace it by something, that would be nice. I don't know if it works as the square root. It's possible that if you denote the whole square root by something, that's possible too. I'm going to try 1 plus tangent. You can try the square root if you want, but can I make a secant squared?
Yes.
I already have it. It's 1 over cosine. So this is dy. So the integral is dy over square root of y. Are you okay? So now the whole thing becomes simple. It's the square root of y raised to negative 1/2 dy. See how important and how useful the substitution rule is? We have an answer?
2.
So this is y to negative 1/2 plus 1 over negative 1/2 plus 1, right? So it's the square root of y divided by negative 1/2 plus 1 would be 1/2, right? Or 2, yes.
2.
So it's 2 the square root of y plus c. Did we get this? And now I have to replace y by 1 plus tangent. So it's 2 the square root of 1 plus tangent t plus a constant c. Okay, here's the last one. Sine x over 1 plus cosine squared. No. We have to use the substitution so that du or dt is in the problem. Do we have a substitution?
Plus
Good power.
Any suggestions?
Would it maybe be cosine squared?
Cosine. If I use cosine squared, I'm in trouble because cosine squared prime is 2 times cosine times negative sine, and I don't have that. So dy equals negative sine x dx. The only thing that I'm missing is a negative 1. I'm going to multiply twice by negative 1. So then what do I get? Negative outside. Negative sine x dx is negative sine x dx is dy over which I know what it is, which is
I put it straight in W and I was confused. Okay.
that's okay. And then I have to go back. What is y? That's it. And yes, nobody likes cosine inside of arctangent. That's for sure. It would have been way more difficult otherwise, without the substitution. This chapter is pretty much done. On Tuesday, I would like to review and finish up with the substitution rule for definite integrals. And then we'll start reviewing. On Tuesday, we'll review. And on Thursday, we'll review for the test.
Are you posting problems?
I will post 6 problems, yes. The test is not next week.
Okay, so we have.
A week after, yes. Yeah.
So next week, we're learning.
Yes, I only have the definite integral, the substitution rule for definite integrals left. But I want to go back and then start reviewing, and we'll review again on Thursday.
So what are we looking at for the next test? Just definite and indefinite?
Just to chapter